Okay. Good morning. Sunrise over here. Today, we are going to focus in digital inputs. Okay. So,
In what?
what we are going? Sorry.
In what? What are we going to focus on?
Digital inputs.
Inputs. Right.
Yeah. Today is input devices. Today's week is input devices. So there are mainly two kinds of input devices, but there are actually three. There are inputs devices that you are reading digital signals. Then there are analog inputs where you are reading voltage. Oh, present is here. And then there are data inputs. You are reading from the serial ports. You are reading data straight away, parsing data from the serial port. And also, we will talk later this week about step response input devices. But today we are going to focus, because we only have half an hour now. We should have started at the normal time, because if Kochi was not going to join, now we have little time. Well, in any case now. Vinyasman, do you hear me? Just someone raise their hand. You are hearing me? Only
No, all are here. We all are hearing you.
okay. Okay. Hi. Long time no see. Since when are you going to be together there? For how long?
No, they are only for today.
Only today?
Yes.
Okay.
This
is. Are you going to finish the machine assignment then?
Yes. We are now fabricating all the designs. What we want. Today we are going to cut that.
Okay.
What is that?
Okay. Today is going to be about digital inputs. So we are going to go back to the circuit board, we are going to modify the Hello World board, the design assignment board today. We're going to assign we're going to modify this slightly, because we are going to implement a debouncer. So yesterday, I don't know if you remember, they were talking about debouncing.
Yeah.
So debouncing, is anyone familiar with debouncing? You know what is it?
I know.
No?
I know.
You know? What about beginners one? So let me share my screen now.
Oh, I know about bouncing. I don't know about debouncing. Sorry.
Debouncing.
But I don't know how they do it actually, electronically or.
Okay. So actually, you need now, for this week and for output devices, you need to start learning how to use the oscilloscope. Okay?
Okay.
So the thing is, when you press the button, ideally the button should do like this in the oscilloscope. Go up to like this. This is the moment you press the button. Here. Press the button here. But in reality, it doesn't happen like this. It doesn't happen like this. In reality, what happens is that there are microelectrical signals that go up and down when this is very, very close to the surface. And in reality, if you look through the oscilloscope, when you press the button is doing like this. Goes up, down, goes up, down, goes up, down. And then goes steady up. So for normal applications, this doesn't matter. Okay, you will not realize that this is happening. And this is about 30 milliseconds. This bouncing, this goes up, down, and then it goes steady. But imagine that you have an application that when you press, so I'm gonna imagine that you have an application that when you send and when you press the button, it does something significant, like counting. Okay, when you press the button, it's gonna count something. In that case, it is important that the bouncing is not occurring, because it's gonna count 1, 2, 3 here in one press. Maybe it's gonna be 7. You never know how many bounces it's going to make the button. So you need to remove the bouncing when you are doing this. Or imagine you are sending some data through the serial port when your button is on high. So you are going to do also this 3 times here. So you need to debounce the button. Okay? For me, in my opinion, because this is digital fabrication, it is better to do hardware debouncing. Okay? But in the industry, because they are making millions and millions of copies and they want to save even every component, they do software debouncing. So there, software debouncing, you can do software debouncing, but for newbies, what I recommend is just doing hardware debouncing. And if you go Google, you hear Google, and you go to the bouncing button, go to images. So you see, this is what actually is happening. So initially the button is off. You press the button, it goes up and down a little bit, and it goes on. And then again, when you release the button, it's doing the same thing again. So it goes off. Okay, so this is the normal bouncing. The ideal now let's gonna search for hardware bouncing. So in reality, what we are doing here is adding a capacitor. Let me see if I find a good image to explain that. What the capacitor is going to do is going to charge. So it's going to absorb these bounces. Okay. Oh yeah, look at this image. This is explaining. This is the ideal thing. So we are in one state, we press the button. It's another state. We release the button. It's another state. But this is what occurring in reality. This is bouncing, and also here it's not shown, but it's occurring the same thing. The bouncing is occurring at also at the release state. So what we do is we add a capacitor. So this capacitor is going to absorb this. Okay, it's going to absorb this bouncing, and also it's going to release slowly. If you look through a oscilloscope, this is what you will see. And I want you to be familiar with using the oscilloscope now. So if you have one, is the time to get it out of the box. So this is what occurring in the oscilloscope, but this is what the microcontroller is reading. The microcontroller is going to read like this, because the microcontroller has a trigger high reference that is going to say everything that is below this trigger reference line is going to be low, and everything above this is going to be high. Okay, so the microcontroller is going to read the ideal situation again. And I want you to research about this today, but this is just adding a capacitor. It's a capacitor after the line. There are here some people also using a resistor. But the thing is, after the you put a capacitor after, okay? Across the, yeah, and most of the people are using 100 nanofarads. So I want you to check your Hello World button board under the oscilloscope, and then I want you to modify, like hacking inside the board. I don't want you to mill a new board, but I want you to hack your board and add a capacitor and check again in the oscilloscope if it is happening like this. Okay. So about the bouncing, this is what I want you to do today about digital inputs. Then, if you have more time today, I want you to have a look at this book. I remember I posted it. This book that you all should have. I want you to go to digital inputs in the basics part. There is a chapter for digital inputs. So I want you to read through this character. It's going to explain, well, things that we already know about the pull-up resistor that we don't put now, because inside the microcontroller there's another pull-up resistor. I want you to look at this UI. See the bouncing thing here again. And here, if you want, but I don't want this, because this is getting the program more and more complicated, and this is for people who has started with programming, including a debouncer program. Sorry. I mean, this is for the industry, what the industry came across to avoid having a hardware debouncer. But because we are doing digital fabrication for the market of one people, I mean, and you have millions of capacitors that you will never use, they will get rust even before you use all of them. I recommend you to do hardware debouncer. If the button you are using is for, I recommend you that use hardware. There are some people using tricks, like they just wait when they detect a button changing the state. They just wait for, say, 50 milliseconds, so there is no bouncing anymore. But I mean, this is complicating the. I think this is complicated the program when you can have like a hardware debouncer. So here you will find also when to bounce, about also hardware debouncing, and this is at the very minimum level. I want you to do that at least. If you don't have one way to check that, okay, could be like doing that actually, sending a serial like polling the button all the time in your code, like you poll all the time if the button is checked in your loop, in your main loop, and then if the button is pressed, you send a serial command, like you send a serial string like hello. Check now what happens when you press the button. How many hellos do you send every time you press the button? Okay, how many hellos do you send? And then modify the circuit at the hardware debouncer and check again how many hellos are you sending when you press the button. This is at the minimum what I want you to do today. Okay, then if you are doing more than this, if you feel like more time, like what I said now about sending the serial message by hello is for the people who doesn't have the oscilloscope. Like if you in Bing RAM, it's not this one. Like if in Bing RAM,
Frank?
yes.
It's been a while since I used an oscilloscope. Yeah, so
well, it's about time to.
Yeah, but there's nobody to.
Huh?
There's nobody to tell me how to use it properly.
Sibu and all of these guys are not here,
Yeah,
so they cannot teach us.
The precautions to take while using oscilloscope.
Well, okay.
And all.
The oscilloscope that you have now is also very automatic.
Yeah.
You hook it whatever you want. Okay, hook it.
Okay. Yeah.
Like you have to hook only. It's not ground, and you hook only for example, the input. You hook it to the input you are going to measure. Okay, and you just press auto mode. It will adapt to the.
You know, AC.
You know, it will adapt everything.
Okay.
And then
So
there is for capturing input. Huh?
The bounce will be recorded as a short for a short time, right? It won't like store the graph of the bounce. I mean, like, it'll happen and then it'll go.
No. You can capture events. I mean, in the past this was like this, but now you have a device that can capture. You can set, I can capture what happens when this goes high, and it will actually capture this. You will see this when you press the button. Which is the oscilloscope do you have?
I'll just check.
Yeah. We have 3.
No, you should have only one. The other is maybe a signal generator.
Yeah, I think it's a function generator and a logic analyzer, something like that.
Yeah.
Yeah, Puneet has just gone to check.
Okay. We are going to move on because we are running out of time. But you post now the brand and make of the oscilloscope. I will tell you how to capture. I will look into this, but you can also look into this. You need to look for capture.
Yeah.
Okay, when you press capture events. So there is one button there that you can capture events.
Okay.
Which one?
It's from you and I. It's DS 1100 1100. Yeah. 100.
Can you write it in driver?
Yeah. Yeah.
You and I. The goal, right?
Okay. So I will look into this later. How do you capture an event? You just capture events, like you set it to capture high to low, or low to high, or both. Okay, you capture this event and it will record sometime before and after that event happened. Understand?
Yeah.
It will keep it like frozen on the screen. You can then measure. You can measure how long this process takes. You can measure how many times this bounce occurs. Yes. You capture events, not the bounce events, but you capture high to low or low to high or both. Understand? There is a trigger. You capture. Okay. You can capture differences or changing state, or only high to low, or only low to high, or things like this. But it's very easy, and then you will see it on the screen and you can measure. I will tell you later how to do this. But then, after this, if you have more time, okay, I want you to read, what is it? I want you to get one of the digital input devices that you have. And for that, you need to go through the inventory. So we have it here. So a switch is a digital input. This is a digital input as well.
So
this
they have
only sorry.
So we are using Python codes and all here because it is more useful mathematically. Many mathematical functions. Easy to
But
math.
I would forget about this for now. He's using this for making an interface. This Python is the interface. Okay.
Okay.
But you can just forget about this, and you just can have an LED in your board, and that's it. You use the LED in your board for doing the sensor. So when you keep it simple. If you want to go this complex, you can. But for the very beginning, like I want you to do this today, literally today.
Okay.
So you get, apart from debouncing the button, I want you to look at one of these digital inputs. Like this motion is a digital input. It's going to release high when there is motion and low when there is no motion. So with the LED, you can measure that. So after you do this, you can either use the same board and hook it to one of the pins, the input from the pyroelectric or the input from the sonar. So this goes to one of the pins of the microcontroller. Then you are going to read high or low. Okay. In this case, it's very simple. If this is high, there is motion. If this is low, there is no motion. Then, if you are measuring,
what kind of motion? Like it can be. Does it have a threshold?
yes, and you can adjust this threshold. You will see. For all of this, you always need to check. With these potentiometers here, you can adjust the threshold. For all these things, you need to check always the datasheet of these components. Okay? So if your component is the HCSR501, you have to read the datasheet before you start doing the project. This will tell you if this is a digital input or if it's an analog input. So for example, if we check this, let me go through.
We have these, right, in stock?
No.
Go to the datasheet of this device. So this device, okay, you see you have to connect it to VCC, to ground, there is a trigger and an echo. So how does it work? If you want this to work, it's not like you are reading all the time. You have to trigger it. So you have to send a 10 microseconds pulse high, and when you do this, you are triggering
the sound, the ultrasonic.
Yeah, you are triggering the microphone and the speaker. So what it's going to do internally is going to do these 8 cycles of sonic sending. And then in the pin, in the echo pin, you are going to read a digital input. And you have to measure this time. Okay? What you are going to read is for how long this high is up. You understand? It's not like the other. The other is if it's on, the other is only sending an on when it's movement, there is off when there is no movement. But this, you have to do 2 things in your code. You have to send a trigger event, so this is going to work, and then listen in the echo input for how long this digital input is high. Okay, when you know the time, you can use the formula, you can derive the formula from the speed of the sound in the air. Actually, I don't know if this works underwater. But if it works underwater, you could use it also as a sonar for, because
The speed of sound will be different underwater, so we got to
yeah,
change that.
speed of sound will be different. So in the datasheet, you will find a lot of data. Okay, and you will find what is the minimum distance and the maximum distance. Okay, it's for 4 meters maximum. Remember what Neil said yesterday, it's only for reflective, if it's a bouncing, so it's not a distance detector. You can use this to detect distance, not a distance detector, because if the, and I have to go very soon now, if the material you are detecting is absorbing the sound, it doesn't bounce, so it will not detect. It will say it's 4 meters. Or if the material is reflective, but you tilt the sound will go in another direction. So it's only for reading distance to something that can bounce back something. For most applications, you can use for distance detection. Also, this is important, measuring angle. All of this data, it's always in the datasheet. For all the input devices, you all going to need to read before the datasheet and see what is the circuit board you need to make for this to work, and what is the code you need to do. So for today, let's keep it easy because this is going to be a long week. For today, I want you to test the bouncing of the buttons, research about the bouncing in hardware, modify your circuit. Ready? Modify the circuit to add the bouncer, and then using this, or if you have time, you mill a new board. You get one of the digital inputs that you have. You might have this one of these two or another one. You check for every component we have in the inventory that you might want to use, if this is a digital or analog device. Today we are only doing digital devices. So if you don't have time, you hook it to an Arduino and you test it. But if you have time, you can mill your board. It's going to be difficult. So
Okay.
that you can do that. Okay. This is the very minimum I want you to do today. It's too bad. See, is there. It's too bad that Kochi could not join, because we should have started before then. We have more things to do. So, big Nenasam, that you are here now. Before I leave, are you together to finish the machine assignment? Or what?
Gyanasham, can you hear us? All right.
Yes,
Hello?
are you together to finish the machine assignment, or?
No, we are here only.
Okay.
Hello.
Okay. So did you receive all the things you have to do today for tomorrow?
By tomorrow we'll get it.
So otherwise, you check the video that is going to post later, Puneet, if you didn't get it. But please do all the things that I asked for this to do today. because otherwise we cannot move forward. If you don't get these basic things today, we will not be able to move it forward later this week.
So what's the
We are doing
plan?
many things this week.
So what's your plan to be for the coming week, rest of the week?
Sorry, what is the plan B for?
No, he's asking what is the plan for the rest of the week?
We need to do analog devices. We need to do step response input devices. That is going to take us at least 2 or 3 days. So this, the very basics, I want you to get it very easy. And we also want to do some of the inputs that are using serial data, sending serial data, like a GPS or I2C or something like this. These are not sending high and lows, but they are sending data. They are sending 25 through the data channel.
What about cameras? Cameras.
That is also serious.
Yeah, cameras. I think cameras is something you can do on your own because it's you don't have to fabricate anything.
Okay.
I mean, there are many tutorials out there. But these things we are going to do this week, they are very low level. Like you have to fabricate and look very deep in the code. Like OpenCV, you get a Raspberry Pi and a webcam, normal webcam, and you can do experiments like this afternoon if you want. There are many. You put this, and there is a program for detecting edges, and then with this, or you can detect if there is. You place it in a car spot, and you record how is the image when there is no car. And when the car comes, you see what is the difference in the camera, and you can make a trigger that says that the parking lot is used, and use this as a car detector. I mean, you can find many applications for that. But there are also many tutorials. And there is no need for fabricating anything for that. It's just your Raspberry Pi and the camera and a little bit of coding. You don't need a fab lab for that. But the things we are doing, we will need to fabricate. And the assignment is we need to fabricate a board, at least one board, attach a sensor to it, and make a code for that. For the camera, we cannot fabricate the board.
Yeah.
We need to use a Raspberry Pi. It's too advanced for our skills to fabricate a Raspberry Pi, even if it's open source. It will take us a lot of time. So I follow up through River, but keep in touch. Let's see if Kochi we can get them to do this today, as well as Bing and Asram. Do the bouncing and choose one input device and hook it to whatever. It doesn't matter if you fabricate the board today, but hook it to something and make it work. Okay? If possible, without the library. Okay? So let's see tomorrow morning how far did you reach. And we will adjust the thing accordingly. Okay? So tomorrow we start at normal time, 9:30, because I wanted to incorporate Kochi, but Kochi is not appearing either, and we have very little time. We start at 10:30.
Okay. Yeah, they can join like at 10:30.
Yeah.
We can start.
We did this last 2 days, and they didn't join either. Okay. Need to go now. See you tomorrow morning.
See you.
Again.
Bye.
Bye bye.